So, hello and welcome back. So, today we're going to focus on this 2026 MIT Integration B exam, and here we have about 20 problems. And the format of this exam says you have to solve these 20 problems under 20 minutes. Okay, I don't think you can get a perfect score from this exam though, because it's not difficult. It's not, I don't see a word where you can solve all of these problems under 20 minutes, but it's basically kept as a filter so that they want to just get who are the best, who are the fastest thinkers, who are the smartest students to do this integration. But probably this video is going to last up to an hour, I don't know, but it may take up to an hour, but none of these problems are that simple. I have solved some of these problems, like I've solved this one before, and also I think this one and this one. But the reason why I want to do everything in a single video is because some of them are very simple problems, so there's no point in doing a video and I'm trying to explain this thing. Although people do this, but it's not my style. I like to solve questions that are at least worthy of being solved, not something that I can look at and just figure out the answer. So let's just focus on this now and see. For the first problem here, which is problem 1, it says what is the integral from negative pi to pi of this times this. So sine to the power of 2025 of x and then cosine to the power of 2026 of x. Now, to evaluate this integral, you need to understand that the integral over a symmetric interval of f of x dx is equal to, number 1, twice of the integral from 0 to a of f of x dx, and is equal to 0. On the first case, is equal to twice of the integral from 0 to a of f of x if f of x is even, but it's going to equal 0 if f of x is odd. So f of x being odd. So this is our case now. Is this function, when you get integral over symmetric interval, the first thing you need to check is if it is even or odd, no matter what, because especially this kind of problems, they are just designed to just like tell you to check if it is even or odd. And if we check here, this is actually an odd function, because sine of x, if you take x to be equals to negative x, sine of negative x is equals to negative sine of x. So because there's an odd power here, you have a negative, and then also, but cosine of negative x is cosine of x, so you're evidently going to have a negative here. So basically this function, which is f of x, equals to sine to the 2025x and then cosine to the 2026x is equals to, is odd. And because it is odd, for this reason the integral from negative pi to pi of f of x dx is equal to 0. Okay, so that is that. What about the second integral? Well, the second integral, to do this second integral, let's observe that, okay, I think I've made a video of this one before, but let's just still do it. The integral of e to the 2026 e to the x, then plus an x dx. Well, you may be thinking, how do I make a substitution here? Because we know that substitution works. First of all, if you try to take u to be e to the x, you are going to really struggle here, because you can get the u to be e to the x dx, of course, but the problem now is that how do you handle this? Will now be e to the power of 20. Okay, yes, it can work. E to the power of 2026 u times e to the x dx, and e to the x dx is du, so this will be e to the power of 2026 u du, and this will be 1 over 2026 e to the 2026 u, and then plus c, where u is e to the x, so you can plug in e to the x here, and that will be the answer to this problem. So number 2 is done and dusted. What about number 3? Well, number 3 is a bit tricky in some way, but it can be managed, because if you look at this integral, you will see the integral from 0 to 2026 of the fractional part of the floor of x. Now, problem is that The integer, this floor of x and ceiling of x, these two functions are actually called integer functions. The reason why they are called integer functions is that it doesn't matter the input, the output would always be an integer. For example, if you plug in x to be, let's say, 20.5, then the floor of 20.5 is basically 20, and the ceiling of 20.5 is basically going to be 21. So it's going to be an integer, and the floor of x tells you what is the least integer that is greater than or equal to x, while this one tells you what is the smallest integer that is more than x. Okay, so this one, the ceiling, this one is the floor. So how do we handle this case? First of all, we have to check for where the floor of x is an integer, because the fractional part tells you, asks you what is the fractional part of that expression. For example, what is the fractional part of 1/3? Well, it's basically going to be equal to 1/3. What is the fractional part of 2? The fractional part of 2 is 0. Fractional part of an integer is, so what is fractional part of 2.15? So it's going to basically be equal to 0.15. So in general, this represents fractional part of x. So fractional part of x. This is the integer part, and this is the this is the floor, and this is the ceiling part of this x. So what we're going to do is that now we're going to split this into 3 cases. So let's start off with this. So we're going to say, let's assume, say 0 is less than or equal to x, less than or equal to 1. In this, this is our case 1. So x is between 0 and 1. If that is the case, then we know for sure that floor of x is going to be 0, right? Yeah, floor of x is going to be 0. Then the fractional part of the floor of x divided by 3 is going to be equal to 0. Okay. Now, what's up when case 2, when 1 is less than or equal to x, less than or equals to 2? Well, in this case, floor of x would be 1. So the fractional part of the floor of x over 3 would be equals to the fractional part of 1 over 3. And this will be equal to 1 over 3. What about case 3? Okay, when 2 is less than or equal to x, less than 3. And then in that case, the floor of x would be 2, and the fractional part of the floor of x divided by 3 would then be equal to the fractional part of 2/3, which is equals to 2/3. Now, what about case 4? When, say, 3 is less than or equal to x, less than 4. Well, in this case, the floor of x here would be 3, and the fractional part of the floor of x over 3 is equals to the fractional part of 3 divided by 3, and this is going to be 0. So we start off with 0, we met this, and now we're back at 0. Now it makes sense to think like, okay, maybe this function is periodic. Remember that you're supposed to solve this problem under 1 minute, so this thing, you don't really have time to check all of this. That is the problem. So the first thing to do is that since you see the pattern, you want to say, okay, since I see the pattern, now let me check if this function is periodic. So what we'll do is that, let's assume it's periodic with period 3. So in this case, f of, let's say 3, let's say x being a multiple of 3, f of 3n plus x. Okay, let's consider this case. Then you have the floor of 3n plus x here now. Then this will be the fractional part of the floor of 3n plus x, all divided by 3. Now the big question we are asking ourselves is that, for this case here now, what is the floor of 3n plus x? Well, because this is an integer, we can pull it out of the floor function. For example, if you have the floor of n plus x, this is going to be the floor of, this is going to n plus the floor of x, if we are sure that n is an integer. Okay, because the floor of x is going to be equals to x if x is an integer. So this case we will have the fractional part of 3n plus the floor of x all divided by 3, and that would give us the fractional part of n plus the floor of x all divided by 3, and this will be the fractional part of the floor of x all divided by 3. So you can see that this is going to be our f of x. So it is clear that this function is periodic with period 3. Okay, it's going to be periodic with period 3. So that means that actually our limit of integration being from 0 to 2026, right? We're taking this from 0 to 2026. So what we're going to do here is that we're going to divide this interval by 3. So we're going to divide 3 by 2026. And then that is 6 times 3, 18, 3, and then 2. Yes, so 18, then 2, then 7 times 3, that is okay, this is 2. Yes, that is 21. So then so you have a 1, 6, so you have 5 times 3. So you have a 1, so you have a remainder 1. So basically 2026 is going to be 675 times 3 plus 1. So what we do is that we have the integral from 0 to 2026 of the fractional part of the floor of x divided by 3 dx. So we're going to split this into the integral from 0 to 1. Okay, how do you say? Let's see. For this particular integral, though, we only need to look at the integral from 0 to 1 plus the integral from 1 to 2, then plus the integral from 2 to 3. Okay, yes, because every other point on the interval, it is going to repeat itself. So it's going to repeat itself in every other point on the interval. So, and also there's a good theorem for periodic function. It says that the integral from 0, there's a nice theorem for periodic function. The integral from 0 to nt plus a is equal to the integral is going to equal to n times the integral from 0 to t, yes, of f of x dx plus the integral from 0 to a of f of x dx as well. Yeah, that is the theorem. That's what I was thinking. So what we're going to do is that we're going to remember that the integral from 0 to nt plus a for periodic function, where t is the period, of f of x dx is going to integral from 0 to n times integral from 0 to t of f of x dx plus the integral from 0 to a of f of x dx. So now in this our case here, now our n is 675, t is 3, and a is 1. So you have 675 times integral from 0 to 3 of the fractional parts of the floor of x divided by 3 dx plus the integral from 0 to 1 of the fractional part of floor of x all divided by 3 dx. Now this integral obviously will be go to 0 because from 0 to 1 the floor of x is 0, so everything here is going to be 0. On this other hand, this part here you can write this as 675, then you have the integral from 0 to 1 plus the integral from 1 to 2, then plus the integral from 2 to 3 of the fractional part of the floor of x over 3 dx. Now the from 0 to 1 this will be a 0. From 1 to 2 this will be 675 times integral from 1 integral from 1 to 2. 1 to 2, you get 1 over 3, right? Plus the integral from 2 to 3 of 2 over 3 dx. So you get 675. Then you multiply this by 1 over 3, and then plus 2 over 3, which is just going to be equal to 675. Yeah. So our answer for this part is 675. So it took us quite long, but at least we got the job done. Now what about this number 4? Okay, for number 4 here, we need to look at the integral from -1 to 1 of all of this. So first of all, let's assume x is less than 0. So let's say we are looking at the integral from -1 to 0 of this f of x dx, where this f of x is this nested interval. So how do we deal with this one? What are we going to do here? Well, since x is completely negative here, notice that first of all, the floor of x, which is our, we're just going to say ji to be the floor of x, then j2 is equals to the floor of x plus the floor of x, which is going to be x plus j1, j1, and then also j3 would be the floor of x plus the floor of x plus the floor of x. So that would be x plus j2 as well. So keep that in mind. So now basically, if x say is less than 0, then j1 here will be negative. So j1 will be negative x. j2 on the other hand will be x minus x, which is 0. On the other hand, j3 would be x plus 0, which is still negative x, because x is less than 0. So our absolute value of x is negative of x. Now, so let's say j4. Of course, j4, we expect j4 to be 0 because you're combining x plus j3, which is going to be absolute value of x minus x, which is 0. So you notice one a pattern here that so long as n is odd, j sub n would be negative x if n is odd, and it will be 0 if n is even. So we have no business with the integral from -1 to 0, because in this our case we have 2026 x's, so we have no business. So we only need to consider the integral from 0 to 1 of j sub n of x. Okay, so let's look at the second investigation for j sub n of x from 0 to 1. Now from 0 to 1, the situation is a bit different, because here notice that in this case here now, j sub 1 is absolute value of x is equal to x, and j sub 2 would be x plus x, which is going to be 2x. So j sub 3 is going to be x plus 2x, which is going to be 3x, because again x is bigger than 0, so absolute value of x is equals to x. So essentially here, j sub n will just be 2026 x. So we are looking at the integral from 0 to 1 of 2026 x dx, which is 2026 times the integral from 0 to 1 of what? Of x dx, which is 2026 times x squared over 2 from 0 to 1, which is 1013, Abi. Yes, so that is 1013. So that is that, and that one is settled. Now let's look at the fifth problem on our list here. So slowly but surely we are making some good progress here, and we will prevail. Of course, we are going to come out victorious. This may look daunting and difficult to do, but before you know it, before 30 minutes now, we are almost done. So look at number 5 on our list. This one is very simple, nothing too much. Just multiply top and bottom by the conjugate. You're going to have the integral of square root of x plus 1 plus square root of x plus 1, all divided by square root of x plus 1 minus square root of x minus 1 times square root of x plus 1 plus square root of x plus 1, right? So in this case, you will have the integral of square root of x plus 1 plus square root of x plus 1, and then at the bottom part, you should have an x plus 1 minus an x minus 1. Okay, so that would be right. No, this is a minus 1. So that would be half times integral of square root of x plus 1 plus square root of, I know this is a minus, square root of x minus 1. Now, simple substitution takes care of this integration because you have a full square root. If you take u to be square root of x plus 1, du would be dx. So basically the first integral is half the integral of square root of x plus 1 dx, which is half times integral of square root of u du, which is half times u to the power of 3 over 2 divided by 3 over 2. So which is going to be 1/3, I believe so. Which is going to be 1/3 x plus 1 to the power of 3 halves. And the same thing should happen for this. How it will not be a plus 1/3 x minus 1 to the power of 3 halves too as well. The second integral should compute easily. So we are done with that part now. So what's this? Now let's look at number 6. Okay, number 6 here is a bit scary, but can be managed though, because I don't really know the identity for this, but I know that cos x is e to the x plus e to the negative x divided by 2. So we know that 1 plus cos x is going to be e to the x plus 2 plus e to the negative x all divided by 2, which is going to be half of e to the x over 2 plus e to the negative x over 2 square, right? Because if you take the square, you have this. If you multiply, you have 2, and if you take the square, you have this. So that would be, so this would be integral of square root of half. Then you have e to the x over 2 plus e to the negative x over 2 all square. So you have a 1 over square root of 2 times the integral of e to the x over 2 plus e to the negative x over 2. I think that should be cos, right? That is twice cos. So this will be going to be 2 over square root of 2 times the integral of cos x over 2, and that should be dx, and that should be 1 over square root of 2 times sine x over 2 divided by, oh no, this will be square root of 2 divided by 1 over 2, right? I think that should be 2 root 2 then sine x over 2, something like that. Should be that. Don't need to waste our time with all of these simple problems though. Once you know what is happening, you should be in good shape. So let's move on to the next problems in our hands. Okay. Now this one here, I mean, it's not do everything one by one though. I should just be doing hints and skipping because okay, this one here. Yeah, this one here now is, how do we go about it? Well, I think you remember if you did elementary algebra, that should be the fact that a to the power of logarithm of c to base b is c to the power of logarithm of a to base b. So you can actually bring this, you can actually swap the role of a and c and it doesn't change. So in this case, 2 to the power of log x is 2 to the power of is going to be x to the power of log 2, right? Yes. So basically you're going to have the integral of 2 to the log x all divided by x squared dx. So you have integral of x to the power of log 2 all divided by x squared dx. So we have an xx, and that should be integral of x to the power of log 2 minus 2 dx. I think that should be equals to x to the power of log 2 minus 1 divided by log 2 minus 1. So nothing difficult here. So that is that. Okay, now let's look at this one here. For this other case here now, number 8. So how do we deal with number 8? We are going to just write it as 0 to 1 over 2, and then you have the sum as n runs from 2 to infinity of x to the n dx. Now notice that this series that appear here of x to the n dx, the sum is to be, as n runs from 2, it will be x squared plus x cubed plus x to the 4th plus x to the 5th plus and so on. So you have an x squared 1 plus x to the 2nd plus and so on. So you have an x squared over 1 minus x. So this is equal to the integral from 0 to 1 over 2 of x squared over 1 minus x dx, and we know what to do here. Of course, I don't have to say that. We write this as x squared minus 1 over 0 minus x. Okay, yes, it will be so 1 minus x minus or plus 1. Okay, dx plus the integral from 0 to 1 over 2 of 1 over 1 minus x dx. Because here I added 1 and subtracted 1, so that should be that. Hopefully I'm not making mistakes here. Hopefully, yes. Okay, so here you write this as negative times integral from 0 to 1 over 2 of 1 minus x 1 plus x over 1 minus x dx, and this is a negative logarithm of 1 minus x from 0 to 1 over 2. So that would be negative integral from 0 to 1 over 2 of 1 minus x dx minus I think that is plus logarithm of 2. Then here you have a negative, you have an x minus x squared over 2 from 0 to 1 over 2 plus log 2. So at 1 over 2, you have a 1 over 2 minus 1 over 4 times 1 over 4 1 over 8. So you have a 4 minus, so you have a 4 times 4, 8. So 3 over 8, I believe so. So you have log 2 minus 3 over 8. That should be the case. So you have, because you have s and 1 over 2, and then you have 1 over 2, 1 over 4, 1 over 8. So yeah, so that should be that. We should be fine with this one. Then for the second one, we are dealing with integration by parts here. So the goal here is to try to reduce the powers of x, of course. That is the goal here. You want to try and get this x to at least reduce. So you want to focus on cos, and you have to write this as integral from 0 to, no, not integral of x squared. Then you have to write a negative cos x prime. So if you use integration by parts, you have a negative x squared cos x, then plus the integral of 2 times the integral of 0, integral of x cos x dx. So this will be negative x squared cos x plus twice, then okay, this is sine, right? So okay, twice integral from integral of x, then you have sine x prime dx. So that would be negative x squared cos x plus 2x sine x minus twice the integral of sine x dx. So that would be, I think, negative x squared cos x plus 2x sine x minus 2 cos x plus c. That should be that. So, and then this one we're going to do here now. How do we figure this out? Okay, this one seems okay. We are halfway through, so this is like 30 minutes now. We are like 10 questions, so we should be done in extra 30 minutes, I believe so, if all things being equal. Okay, now this one here, now we should just expand it up. You will have an x squared minus 2x plus 1 divided by 2e to the x plus x squared plus 1. Now I'm going to add the bottom to the top. I think I should try this one. So I have 2e to the x plus x squared plus 1 minus 2e to the x minus x squared minus 1, and then I'm going to have x squared minus 2x plus 1. So where I'm going to cancel out this x squared. What's x again? Then I'm cancelling out this 1. Everything is divided by 2e to the x plus x squared plus 1. So when all of this is said and done, I'm getting 2e to the x plus x squared plus 1. So I'm getting minus 2e to the x, and then 1, this one with alright, then okay, this we have minus 2x, and that is all divided by 2e to the x plus x squared plus 1. So this will be just 1 minus 2, then you have e to the x plus x, all divided by 2e to the x plus x squared plus 1. Now if you place it together, now basically this integral here will be the integral of all of this, and that would be just x minus, I think if you take u to be 2e to the x plus x squared plus 1, du would be 2e to the x plus 2x dx. So that would be 2 of e to the x plus x dx. So that this will be integral from 0 to du over u. So that would be x minus the log of 2e to the x plus x squared plus 1. We don't even need the absolute value because everything here is always positive. So that is that. So we're done with number 10. And number 11, this one is somehow strange and weird though, but I think we can survive this. It says we should find the integral from -1 to 1 of the maximum value of this. Now, what is the maximum value of this expression? Well, we don't know. Just hold on, let me get a glass of water, okay? So yeah, I went to take some fine water. So how do we handle this one here? Well, I don't really know though, because you can't just this 0 you're seeing, you can't just drop 0. You can't just, okay, let's just drop the 0 and just do the integral from -1 to 1 of square root of 1 minus x squared minus 1 over 2 and dx, because at some point this is negative. So square root of 1 minus x squared minus half at some point is negative. So at some point the maximum value of this expression is 0. So we need to be sure that square root of 1 minus x squared minus half we need to be sure that this is bigger than 0 before we can claim it is a maximum for this case. Okay, now to claim that, to figure this out, what we do is that we need to be sure that 1 minus s squared minus half is bigger than 0, which means square root of 1 minus s squared is bigger than half, which means we can square both sides. You get 1 minus s squared is bigger than 1/4, and basically 1 over 4 is less than, 1 minus 1/4 is less than x squared, or that s squared is bigger than 3/4, or x, or you, from here you can get negative square root of 3 over 2 is less than x, which is less than square root of 3 over 2. So only when x is within this interval do we have this expression becoming positive. If x falls outside this interval, everything is negative. So we're going to configure this and say, okay, I think it's better going to do this. So we're going to configure this and say this is equals to the integral from negative square root of 3 over 2 to square root of 3 over 2 times what? Square root of 1 minus x squared minus 1 over 2 dx. So, and then this integral, for this one, the first one, this will just be negative square root of 3 over 2 times square root of 3 over 2 square root of 1 minus x squared, and then you have a minus half times integral from negative square root of 3 over 2 times square root of 3 over 2 times dx. So this one should be 0 because it's symmetric interval and the function is this 0? Well, it's going to be equal to x, and we're taking the integral from negative square root of 3 over 2 to square root of 3 over 2. So you have square root of 3 over 2 minus negative square root of 3 over 2. Okay, no, it's not 0. So that would be square root of 3. Yeah. So with the half, so everything here contribute to square root of 3 over 2. Now for this part here, this part is just take x to be sine x. So you have this integral from negative pi over 3 to pi over 3 of cosine squared x dx. And because this is an even function, right? Yeah. Let me be sure. So this will be twice the integral from 0 to pi over 3 of cosine squared x dx. And this is going to be the integral from 0 to pi over 3 of 1 plus cosine of 2x dx, so which is going to be x plus sine of 2x over 2 from 0 to pi over 3. So that will going to be pi over 3 plus sine of 2 pi over 3 is equal to plus square root of 3 over 4. Okay. Then we're going to subtract it from square root of 3 over 2. So 1/4 minus half is negative 1/4. So this is going to be pi over 3 minus square root of 3 over 4. So I believe that should be the correct answer. Now let's see, for this part here, this one here, how do we go about this one? These are the kind of those, I don't like all these problems whereby you, anyway, let's do what are we going to do. Because the thing is that there's so many work to do. You just have to start by setting y to the square root of s squared plus x plus square root of x squared plus x plus and so on. Then you get notice that y squared would be x squared plus x plus y. So essentially y squared minus y minus x squared plus x is 0. Now this is a quadratic equation where we need to solve for y, because we need to get an expression for y. So you get using the quadratic formula that ax squared, we know the automatic formula, ax squared plus bx plus c has a root at x equals to negative b plus or minus square root of b squared minus 4ac all divided by 2a. So using this quadratic knowledge, or whatever I'll call it, we will say y will be negative b, which is 1. This is a b. 1 plus or minus square root of b square, which is 1, minus 4ac, minus 4a is 1, c is negative x squared, negative of x squared plus x, all divided by 2a, all divided by 2. So you will have 1 plus or minus square root of 1 plus 4x squared plus 4x. So which is 2x plus 1 square is 4x squared plus 4x plus 1. Okay, thank God. I was thinking that this will not help us. So this will be this would be 1 plus or minus square root of 2x plus 1 square all divided by 2. So that would be equal to 1 plus or minus 2x plus 1 all divided by 2. So we have two values for y. So y is 1 plus 2x plus 1 over 2, or y is 1 minus 2x plus 1 over 2. So y would be x plus 1, or y would be negative x. Now y cannot be negative because x is positive. X is from 0 to 1, as you can see here. From the limit of integration, x is from 0 to 1. So if y is now negative x, that means that y is negative, and this is impossible because you can't have a square being negative. So y is not negative here. So y has to be positive. So basically we have to now run back and take y to be x plus 1. So basically we're doing the integral from 0 to 1 of x plus 1 dx. So that would be x squared over 2 plus x from 0 to 1, which is half plus 1. I think this is 3 halves. Yes, it should be 3 halves. So you can see why I don't like those problems, because they take so much time to do. Now this number 13 is number 13 is not so. Let's see. And this is nothing serious here. I think we need to only find the value of cosine 5x, right? Yes. I think we need to find the value of cosine of 5x. Yeah, because if you look at the form, so because cosine of x is e to the x plus e to the negative x over 2. Cosine of 5x. Oh no. Okay, cosine of x is the real part of cos x plus I sine x. So cosine of 5x is how do we even do this? I'm thinking about the easiest approach for this problem here. Should I use this complex number method? I don't want to confuse myself. Should I use cosine squared and multiply it by cosine squared and then by cosine of x? That should give me cosine to the 5th power. Okay. Let me just use the simplest. No need for all this nonsense. Let me just try. What I will just do is I'll just say cosine of 5x is cosine of 3x plus 2x, which is cosine of 3x cosine of 2x minus sine of 3x and then sine of 2x. So that would be cosine of 3x, not known, but cosine of 2x is known. So this is cosine of 3x times cosine of 2x is cosine squared x minus sine squared x, and then sine of 3x is not known yet, so this is sine of 3x, and then sine of 2x is 2 sine x cosine of x. So you have this would be 2 cosine. Does it concern? Okay, let's just leave it as this. So let's just leave it as this power. So let's just find cosine of 3x and sine of 3x. So that's that. Well, cosine of 3x again is basically cosine of 2x plus x, which is cosine of 2x cosine x minus sine of 2x sine x, which is cosine of 2x is okay. This is cosine squared x minus sine squared x times cosine of x minus sine of 2x is 2 sine x cos x times sine of x. So when all is said and done, this is cosine cube x minus sine squared x cosine of x minus 2 sine squared x cosine of x. Now I'll just arrange it in terms of cosine only. So this is cosine cube x minus, so you have a sine squared, that is 1 minus cosine squared x times cosine of x minus 1 minus cosine squared x times cosine of x. That will be cosine cube x minus cosine of x plus cosine cubed x minus twice cosine of x plus 2 cosine cubed x, right? That would be 4 cosine cubed x minus 3 cosine x. Okay, so we have a formula for cosine of 3. What about sine of 3x? We should find the formula for sine of 3x. Sine of 3x is sine of 2x plus x, which is sine of 2x cosine of x plus cosine of 2x sine of x, which is going to equal 2 sine of x cosine squared x plus cosine squared x minus sine squared x times sine of x, which is 2 sine of x 1 minus sine squared x. Then you have plus 1 minus sine squared x times sine of x minus sine cube x. So that would be 2 sine x minus 2 sine cubed x plus sine x minus sine cube x minus sine cube x. So that would be 3 sine of x minus 4 sine cube x. So we have proven the identities for this and this. Now let's go back. This is going to be lengthy, but We don't. There may be other means, of course. If you use complex numbers, it can be faster. But I've already done so much math here. I don't want to confuse myself, so no need for such things. It takes time, but I'm not in the exam hall, so I have all the time in the world. If you are tired, you can just pause the video and go take a glass of water and come back and join me and enjoy yourself. So no need for rushing. So let's see. We have cosine of 5x. So we have cosine of 5x to be equal to cosine, what is it? Cosine of 3x times cosine squared x minus sine squared x. Okay, we have cosine of 3x times, instead of this, I just said tensor cosine, like 2 cosine squared x minus 1. I think I have a cosine to the fifth in the original question. Okay, yes, so just write it as this. Then we are subtracting this by sine of 3x times what? Times 2 sine x cos x times 2 sine x cos x. So cosine of 3x is 4 cosine cube x minus 3 cosine x times 2 cosine squared x minus 1. Then minus this is going to be, I think, 3 sine x. So you have a 3 sine x minus 4 sine cube x times what? 2 sine x cos x. Okay, so making some progress, which is going to be 2 times this, that is going to be 8 cosine to the fifth power of x minus 4 cosine cubed x minus 6 cosine to the fourth power of x plus 3 cosine of x, and then this is going to be minus 6 sine squared x, and then cosine of x, and then plus 8 sine cube x, and then no, sine to the fourth power of x, and then cosine of x. So let's check the form of the problem. Sine to the fourth, cosine cube, sine squared. Sine to the fourth, cosine cube. So I think we are almost done there. Okay, so it seems that this approach does not yield much fruit. Okay, it does not equal cosine to the fifth. So what do we do from here? From here we can definitely expand, but let's see. Okay. If you subtract all of this value from this, if you subtract 10 cosine cube sine squared and 5, let me see. Okay, I think I will have to make a separate video of this. Getting a bit confusing. Now let me just simplify to the end though. Let's see if anything happens. Then sine square cosine. Okay, I have a c sine square cosine. Do you have a sine square cosine here? So it deserves a separate video. Quite super long. I'm going to make a separate video of it so I can give in detail explanation because it's quite super long for a combined video. What about this 14? Let's look at problem 14. Okay, here I think you have to take u to be square. I've saw this one before. Take u to be square root of x, then du would be 1 over 2 square root of x dx. Okay. So that means u 2u du is going to be dx. So you have 2u tan inverse of u du. So that is twice of, I think this is what you do integration by parts. So u squared over 2, or just remove it and just put u squared over 2, and then I think so. Yeah, so you get tan inverse of u, and then minus the integral of u squared over 2 times du over 1 plus u squared. So you get u squared over 2 tan inverse of u minus half. I think you have s squared plus 1 minus 1 over s squared plus 1 dx. So you have u squared over 2 tan inverse of u minus half of u plus I think you have tan inverse of x plus c. So that settles that part. Now for this number 15, how do we go about that? Okay. Alright, so for this part here, we're going to take let me adjust. So for this part here, we're going to take x, set n to be the floor of x. Okay, so let's see for this first problem, number 15. The floor of the ceiling of x would be the floor of n. So the floor of n, because okay, wait. Do we have the floor of the ceiling of x? What is the ceiling of x? Because since the floor of x is n, that means that the ceiling of x is n plus 1. So the floor of the ceiling of x would be n plus 1. So that this one is equals to n plus 1. What about the ceiling of the floor of x? Well, the ceiling of the floor of x is going to equal the ceiling of n, which is going to be equal to n plus 1. So you have also n plus 1. What about the fractional part? The floor of the fractional part of x. Well, the fractional part of x, if for x being an integer, is going to be 0, because what's the fractional part of, how do we reconcile this aspect? Because the fractional part of x is going to be the floor of x, x minus the floor of x. Okay, so you have the floor of x minus the floor of x. and then that would be the floor of x minus the floor of x. So that would be 0, I believe, though. We'll get it 0 here. What about this part, the fractional part of the floor of x? Well, this will also be 0 because the floor of x is n, so the fractional part will be 0. What about the ceiling of the fractional part of x? Okay, this 2 should also be 0 as well, because the fractional part of x, the ceiling of that would be yeah, these 2 should go to 0. So everything will be from 0 to infinity of 2n, sorry, from 0 to 1000 of 2n plus 2. So we're looking at the sum. Because we're looking at the sum from n equals to 0 to n equals to 1000 of this integral from n to n plus 1 of then you have 2x, so you have 2n plus 2 dx, so that would be the sum as n equals to 0 to 999 of twice of n plus 1. Okay, so that would be equal to twice the sum as n runs from 1 to 1000 of n, so that would be twice of, I think we have a 1001 times a 1000 divided by 2, so I think you have, this should be 1,000,001 or something. So you can use a calculator to check the answer for that part, but for now we are done with this part. Okay. Now this part here, I solved this problem on my channel. I don't know if maybe it is worth solving again, but the basic thing here is to just write this as cosine of x times 1 over I think that would be cosine x over sine x times 1 over cosine x, and then you write this bottom as sine x over cosine of x times 1 over cosine of x. So that would be okay, that would be cosine squared x over sine squared x divided by sine squared x over cosine squared x. So that would be square root of cotangent to the 4th power of x, and that would be cotangent squared x. I think that would be negative cosecant squared x. And so the right, because you have the sine squared x plus cosine squared x equals to 1. So divide by both sides by cosine or sine by sine, you get 1 plus cotangent squared x equals to cosecant squared x. So this case will be cosecant squared x minus 1. So this integral here, dx, will be negative cotangent of x minus x plus c, I believe so. So now let's move on. Now this one here, we already also have done this, but I think this is the last 4 we are doing today. So you have the integral from negative infinity to plus infinity of e to the negative x squared over 1 plus e to the 2x dx. So this case here now, we have done it on this channel, but what we did here is to write this as negative infinity to plus infinity of e to the negative x squared, I think modulus of e to the negative x, e to the negative 2x all divided by 1 plus e to the negative 2x dx. So when you take u to be negative x, du is negative dx, and then you have, from instead of limits of integration for to be from negative infinity to be to plus infinity, so this will be plus infinity of the negative infinity of e to the negative u squared e to the 2x all divided by 1 plus e to the 2x negative, so e to the 2u negative du. So this would be integral from negative infinity to plus infinity of, let's go back to s, e to the negative x squared e to the 2x all divided by 1 plus e to the 2x dx. So let's come, this is our, let's say this is our I. So that means 2i would be, first of all, the integral from negative infinity to plus infinity of e to the negative x squared, that is the original integral, 1 plus e to the 2x dx. Then the other integral is negative infinity to plus infinity. This new one is negative e to the negative x squared e to the 2x over 1 plus e to the 2x dx. So if you combine, you have negative infinity to plus infinity of e to the negative x squared 1 plus e to the 2x over 1 plus e to the 2x dx. So when all is said and done, you have negative infinity to plus infinity of the negative x squared dx, which is the square root of pi, so-called Gaussian integral. So I will be square root of pi over 2. So now this 18, when you look at this 18, you should know that something should cancel out here. The reason why something should cancel out here is that normally in mathematics we don't have any this integral does not exist yet. Let me take out. Yeah, this integral of the integral of sine x over x dx does not exist. Although if you take the 0 to infinity, that would be pi over 2. Yeah, it's called Dirichlet integral, but the antiderivative, this sine x over x dx, actually is called the sine integral of x. So it does not exist here. So I'm sure that something should cancel out. So I can't touch this one yet because there's no value for this. I'm going to start with this, and I believe that something should cancel out with this. So I have sine squared x over x squared dx. So you have if you do integration by parts, negative 1 over x sine squared x. So you have plus integral of 2 sine x over x dx. So okay, take x to be 2u, then you have negative sine squared x over x plus, you take x of d, then dx will be 2 du, then dx over 2 will be du. So this will be twice the integral of sine of 2u divided by 2u times dx is 2 du, right? Dx is so dx 2 times du. Okay, so that is times 2 du, right? So which is going to equal so negative sine squared x over x, and then plus 2 times integral of sine 2x over x dx. So I'm having extra 2 here. Why is there extra 2? Okay, I think maybe to avoid mistakes, let me just start and see. That should be a cancellation. I don't believe the answer should involve a sine integral. So you have the sine squared x over x squared dx, which is sine squared x is half of 1 minus cosine of 2x over x squared dx. that would be half of integral of dx over x squared minus half of integral of sine 2x, no, cosine of 2x over x squared dx. So that would be negative 1 over 2x squared, then minus 1 over 2. You have a negative 1 over x times cosine of 2x. Then you have plus the integral of 1 over 2. Then you have 2 times negative 2 times negative 2, derivative of cosine is negative sine, so negative 2 sine of 2x all divided by x dx. So that would be negative 1 over 2x squared minus plus cos 2x over 2x, and then minus the integral of sine 2x over x dx. So that's why I was saying that they should cancel, but I don't know why I'm getting a plus sign. Let me check. Okay, all of this has to multiply by negative. Yes, so all of this has to multiply by negative. So this will be a okay, let me see. Okay, this has a negative already. So this will be a plus sign. So this will be a plus sign too. So that should be a plus here and a minus here. So yes, this plus here and this minus here should cancel out. So everything should be negative 1 over 2x squared minus cos 2x over 2x. So that should be the answer. Here, 19 and 20, do I really have to do them? Here you take u to be log x. Okay. Du will be 1 over x dx. So you have the integral of log u times log of okay, if you take u to be log of log x, then du would be 1 over log x times derivative of log x, so 1 over x dx. So everything here would be du. So you have the integral of u log u du. Okay, this can be done by integration by parts. Let's just do it though. Okay, so that would be u squared over 2 log u minus 1 over 2 u squared times 1 over u du. So that would be u squared over 2 log u minus half of the integral of u du. So that would be u squared over 2 log u minus u squared over 4 plus c, where u is log of log x. And this one here is I already did the full solution. You can just check check this playlist. You're going to see this problem. I already solved this. It took me like 70 minutes. So don't point in putting extra 70 minutes here for this problem. So that is that. So this is the full solution for. Check my YouTube playlist, please. Check the YouTube playlist. You're going to find this solution. So thank you very much for watching. Effectively, after 1 hour 30 minutes, we have been able to solve all of this MIT integration B exam. Although we're going to come back to this one here. No need to fry my brain too many times here. Maybe require some trick, but that is that. So thank you for watching, and please do subscribe to the channel. Bye, and please do have a nice day.